Dear students, today we are going to talk about the application of electric and magnetic field to select the charged particles having particular velocity. Means that way we shall be having a collection of group of all such charged particles which are having same velocity, that means having same kinetic energy if only one type of charged particles having same mass are there. So let us start this. How we are going to do it? We have two electric field and magnetic field at 90 degree to each other. They are along y-axis, positive y-axis, and along positive z-axis. And we take that the charged particle is moving along positive x-axis with a velocity v, and the charged particle is having charge q. While it is moving in electric and magnetic field, the electric Lorentz force acting on the charged particle moving with velocity v will be equal to the charge into electric field, which will be vertically upward, that is along the direction of electric field, and the magnetic Lorentz force will act vertically downward, will be given by the relation q into v cross b. Since velocity and magnetic field are at 90 degree to each other, therefore the magnetic Lorentz force will be simply the product of charge, velocity and magnetic field, their magnitudes only. So that way these two forces, the electric Lorentz force is acting vertically upward, and magnetic Lorentz force is acting vertically downward. Therefore they are in opposite sense. And if the two forces are equal, in that case the charged particle will keep moving along the original path of the charged particle, that is along positive x-axis, and otherwise it will deviate. If the velocity is different from the ratio E by B, the charged particle will deviate from its path. Let us see how we are saying it should be E by B. If the two forces are equal, then we can equate QE is equal to QVB, and because you see direction of motion and magnetic field are at 90 degree to each other, therefore their cross product will be given by the product of their magnitude multiplied by the charge itself. So that means Q is cancelled, so velocity, magnitude of velocity is becoming equal to E by B. And here you see, if the velocity is E by B, the ratio velocity of V is the velocity of the charged particle is equal to the ratio of electric field and magnetic field applied over here. Then in that case the charged particle will keep moving along the original path, that is positive x-axis. And if that is not the case, if the velocity is greater than or smaller than this ratio E by B, the charged particle will deviate either way. For example, if the velocity is greater than E by B, that means the particle will bend downwards, because in this relation if you feed the value of V is equal to greater than E by B, then that means this force will be greater than the electric Lorentz force. Similarly, if the velocity is less than E by B, then the particle will move upward, because if you put the value of V over here, it will be less than E by B, and therefore the magnetic Lorentz force will be smaller than the electric Lorentz force, so the charged particle will be moving upwards. So that way, whatever the case may be, if the velocity is equal to E by B, it remains undeviated, and otherwise it will deviate from its path. That means only those charged particles will be allowed to move along x-axis and will be allowed to stay together, which is having the velocity value equal to E by B. So that means we are in a position to select those charged particles which is having a particular velocity v, and reject all those charged particles. That means the charged particles are forced to be deviated from its original path, and when they are deviated from the original path, we keep absorbing walls around the beam of the moving charged particle. These walls absorbs those stray charge particles which are bending from their path. These walls absorbs them, and so we are left with only charge particle having particular velocity. And since each charge particle are of same nature, their masses are same, so all the charge particles will have same kinetic energy, and that means we will be able to create a monochromatic beam of charge particles, means having same kinetic energy by use of two cross fields, electric field and magnetic field. This has many experimental applications you shall learn in senior classes. Thank you and have a nice day.